Hello and welcome to another exciting breakfast with Unity. So yesterday we did some event stuff, and it was really cool. And we used C Sharp's event delegate methods of setting up event systems. And while I was after the episode, Patrick here asked me a question. Wait, I did switch the screen. Yeah. Patrick here asked me a question. Could this be done using Unity's new event system? And I didn't really know about a new event system other than the one that was used for UI events. But evidently the one that's used for UI events is actually available to be used in general in Unity 4.6 beta and above. So, and I started playing with it, and it's really awesome. So we're going to look at it a little bit today. It's used in a slightly different pattern than what I was showing for the C Sharp event system. The C Sharp event system is perfect for setting up a broadcast subscriber model. This is more for setting up a specific call. It's a callback system. It's for setting up if a script finishes, you can have it tell another script or another set of scripts that it's done or things like that. So we're gonna look at it right now. So, what we're going to do first... So there's a couple problems in this scene, too. Maybe I should show corrections first. I don't want to deal with that right now. Let's just play with this. So, I'm going to create a... should we do this with a fresh scene, or should we just play with this? Let's just play with this for right now. I'm going to duplicate this scene. We're going to call this UnityEvents. And there's a couple bugs in here. I might note them while we're playing around with it, but we're going to use the scripts anyway as is just to see... actually, I'm going to create a whole new thing. Let's just create a new thing here. That way we don't have to be messed up with this. So I'm just going to create a new scene. Don't save, we don't care. And what we're going to do is I'm going to first show you how to create a very basic Unity event system. So we're going to call move forward with callback. Let's just actually let's call it move to goal with callback. And so what we're going to do here is we're going to just create a very basic script that moves us from a position to a goal. And we're just going to do it using a coroutine. It's going to be a pretty basic setup. So public float move time. This is going to be a tween, effectively. 1 point equals 1.0 f public transform target. I like to usually put these above other things. That's just personal preference. And what we're going to do is we're going to go into start and invoke a coroutine. So we're going to start coroutine, and we're going to call this coroutine move to goal. No, just move to goal. We don't want to overload what we already have there. And we're going to call this move to goal, and it needs to be an IEnumerator, so this coroutine IEnumerator. We've done this many, many times on the main show, and probably a few times on Breakfast with Unity as well, but I'll go over it real briefly here. So when you're in an IEnumerator, you can get out of it with yield return null, and you will be back to where you were at when you were started running. So we want to basically run this a frame at a time. And so we're going to set up a time variable, float t equals 0.0 f, while, actually, yeah, let's do it, count forward. While t is less than move time, transform.position equals vector3.lerp. Okay, so we need from, to, and a t. So let's set those up real quick. So vector3 start point position equals transform.position, vector3 goal position equals target.position. And so then we just do start position goal position and t divided by move time. And then we do a semicolon, a yield return null, and at the end we just explicitly set transform dot position equals equals target dot position. So what this means is we start the coroutine, it goes into here on the first frame, and it sets up a time variable. Oh, and I missed another really important step. T plus equals time dot delta time. If we didn't have that, we would have crashed because this would have just become an infinite loop because t would never become greater than move time. So what this does is it comes in here, hits this while loop, adds some time to t, moves the position based on t, and yield return null. So this means that we stop on this frame, it goes to the next frame, starts back here, goes back to the top of the while loop because move time has definitely not been a second yet, and it does it again, and it does it again, it does it again, it does it again until you're finally past move time when we should be at the position, and then we just fall through, set the transform position explicitly to the target position, and then we're done. We're out. We're done. So what this does is if we just create a little, excuse me, a little cube. Yeah, let's create a directional light too, because why not? And then if we create an empty game object, and we move this game object to another position like here, and then we put move to goal with callback on our cube, and we give it a target of this game object. I'm going to call this cube target. We're going to hit play, and in theory, in about a second, it should actually probably will move there too fast. Oh, no, it won't. Why didn't it? We put the script in there. Start coroutine, move to goal. This is a linear interpolation, so it should go between start position and goal position based on the time. Huh. It's not moving at all. That's a little weird. I would have expected it to do something, like crash or something. T equals 0. T is less than move time. Move time is 1.0. It is 1, right? Let's set it to just like 5 real quick, just to make sure that we're not... Huh. Definitely expected that to do something. What did I do wrong here? Move to goal. I'm going to set up a debug log. Debug.log coroutine started. We haven't even gotten to the fun stuff yet. Debug.log coroutine looping. Let's just try that. Oh, now it works. I must have not hit save. Hate it when I do that. File, save. I should always check that more readily too, but I always just assume that I've done something wrong. So I definitely don't want this to be 5 seconds now. Let's just make it 1 second so that it gets over there real quick. So in 1 second, boom, it's there. Yay, it works. So what we're going to do now, though, is we're going to actually make a callback for it. So what we can do is we can create a public Unity... Oh yeah, we need to actually... So for this, we need an extra namespace. We need a specific namespace of UnityEngine.events. I think this is what we need. So now if we do public event Unity event, here we go. Public Unity event, I'm going to call it callback. And we hit save here. Here, actually I'm going to call it at destination callback is what I'm going to call it. I'm going to be more specific. All right, so Unity event at destination callback, and we go back in here, and we'll get this fancy new interface if all goes well. Yes, it did. At destination callback, here it is. So this list is empty. So what we can do here is we can have it do something when it gets to the goal. And we can have it do things that are just built into objects if we want to. So like if we wanted the cube to just die, we could go into the cube, we could choose, okay, maybe we can't do die. Yeah, we can't do die. But we could do, we could disable something, we could actually do a send message. That's interesting. Let's see. There's not a whole lot of exciting things we can do here. Let's go to the mesh renderer. Let's make it so that it disappears. So we're going to do mesh renderer bool enabled, and we're going to check it so that it is not enabled. And so if we hit play here, when it gets to the goal, it did nothing. So that didn't work. Why didn't that work? Oh, because we didn't actually call our callback. Of course. So the other thing is, so we define this here. We need to actually invoke this. So when we get to our goal, we're going to set our position, and then we're going to say .invoke. And this is not to be confused with the other invoke. But this means that we want to run this callback. Like this just calls whatever things that we've done here. So now if we hit play, this should work now. So when it gets here, its mesh renderer should disable. Boop! It just went away. You can see the mesh renderer is disabled there. You can also do multiple messages. So like if you wanted to, let's see what we do here. What's a good example here? Let's make a little contrived example real quick. So let's randomly move function is what I'm going to call this. And all we're going to do here is we're just going to do void random move. And let's go ahead and create a couple variables in here. Public float radius. That's actually all we need. And we'll call this 1.0 f to default. And what we're going to do is, in random move, we're just going to say transform dot position equals transform dot position equals transform. Actually, we'll do plus equals random dot inside unit sphere and times radius. I definitely messed something. Oh, I need an equals here. So that's all this function does, and this will do nothing if we attach it to the game object. If we just put this on the cube target, it's not going to do a whole lot. Oh, okay. So yeah, it has the radius. I'm going to make the radius like 5. Actually, let's make it 3, 2, because this will basically be Brownie in motion. So if we hit play right now, nothing exciting is going to happen. The cube's just going to go over there and disappear. And actually, it disappearing is probably not going to be particularly useful. Is there something I can do here that will be visible but doesn't make it invisible? Let's just turn off the box collider, just so that we see that this unchecks when we get there. And then let's add another thing here. We're going to add to cube target. We're going to grab our randomly move function and invoke. Oh, we don't have it here because this needs to be a public void random move. Save. So now this should show, I'm going to give it a second. Random, okay, well it's not showing it here. Why is it not showing it here? Oh, now it loaded it. All right. Random move, there it is. Click on random move. And so now if we hit play, when it gets there, it should, oh, yeah. Well, the cube target now should be in a different position than it was, and it is. I was expecting the cube to actually follow to the new position, but that didn't happen because we don't reinvoke the goal. Yeah, this is not the best example for this. But you can see how this would work. I really wanted it to chase that goal when it started moving. Oh well. So these two things are, man, we're already 15 minutes in. I told you it was going to be a long episode, and it is. So this is already really powerful. Is a little different than what we showed yesterday, because yesterday we were doing the subscriber system, so the objects were like, I want this callback, and there was this other thing that said, I have this callback. So basically you'd be like, hey, I want that callback, and then it would call all the things that said they wanted it. In this case, we're defining it on the object, so we're saying, hey, I want other objects to get this callback. And it's still super useful, and you can see that this is something that this enables you to create some event-based logic that was otherwise really difficult to set up in Unity, at least in the editor. Like, it was super easy to do in Unity just in general. Like if you wanted to set up things to happen in script, you could set them all up in script very easily. But if you wanted to do callbacks and have them exposed at the editor level, this was really difficult, and now it's super simple. Now, I want to do... Actually, I got an idea. Let's cross-link these. Let's do void... Actually, let's do public... let's try something. I'm curious about order of operations. So we're going to create a public remove is what I need to call it. That's such a stupid name. I'm not going to call it this. Public void move again. So what we're going to do is we're going to just run start coroutine move to goal here. And I'm going to see what happens if we add that as a listener. So we just give ourself here the cube. We grab it, move again. And so now maybe this thing will just follow. Let's see if this works. It did. So every time it's getting to a goal, if we go into the scene and look at cube target, every time it gets to a goal, cube target runs this random move thing. And every time that it gets to the goal, it reruns that. And I believe this proves that there is a direct order of operation here. So like if we were to move this, can I just drag? I probably can't just drag, can I? Nope. So if we were to remove this and remove that and add them back again, but in the opposite order. So if we added cube to... Oh, this will still work, but it'll actually be doing things a little bit differently. This will probably look exactly the same. I'm going to do move again, and then we're going to do... This is just going to cause a frame delay, I think. And randomly move function, random move. So if we hit play now, it'll probably look exactly the same. Nope. Nope, definitely does not look exactly the same. So the reason it's doing it oddly now is because we're moving we're telling it to move to the goal again and then randomly move, as opposed to randomly move and then move to the goal. So the order of operations is preserved here. So keep that in mind. So that's the reason we could get away with that little contrived example that I just made up with randomly move function first. But you can see how freaking powerful this is. Like this allows you to do a lot of cool stuff. I'm so excited about this, actually. So now there's more, though. There's actually a big layer beyond this, and this layer is not very well said in the information here. So if you go to UnityEvent, there's no example. This sucks, but I've given you an example now. You basically go in, you set up a Unity event. When you want to call it, you do invoke, and then you set up everything that you want to call or change in here, and then it's done. You're done. Now there's also these awesome templatized ones with multiple parameters. So like this one is a zero argument persistent callback. And what that means is this really can only call something that only has a call. Like if we look at our functions here, it's move again. We don't have any parameters in here. We look at our function in the cube target. If we look at randomly move function, wait, no, this has no parameters in it. We can actually call stuff with parameters by using the templatized versions. Now, they again don't have examples here, I figured this out this morning, though, so this is good. And they do say just enough to figure it out. So if you wish to use a generic Unity event type, you must override the class type. So what that means is, let's see, what should be a callback for the move to goal? Let's just call back with our position. I don't see how we could... what can we use to figure that out? We already know the position because we're already kind of a target goal, so this is really stupid. Can I make up something else that's more exciting? Yeah, let's do something more exciting. Let's do a create C# script, or let's create a script called raycast with callback. All right. So this is going to be hot. So we're going to have to create a subclass here first. So we're going to have to call this a public class, and I'm going to call it raycast hit callback is what we're going to call it. Actually, and you know what? I'm going to go ahead and define this within the class, so that way, if someone else happens to make something called this, it won't conflict, and we really don't want it to conflict. So, so public class raycast hit callback, and what this callback is going to be, so what does the magic here is we need to inherit from, which is not going to be in there. We need to do UnityEvents, events, and then we're going to inherit from UnityEvent. But we're going to have it use a parameter. And so the parameter is going to be raycast hit. That's going to be the parameter. And this is going to be a single parameter thing. You can actually have up to 3 separate parameters up here, but we're just going to do one for this example. And that's actually all you need. You don't even need to fill anything else out. We're done. So now what we do is we do a public... Oh wait, there's one more thing we have to do. We have to make this serializable. So system.serializable. If you don't do this, it will not show up in the editor. So, and we don't need a semicolon there. What are we doing? So public raycast hit callback. Callback. And all we're going to do is we're just going to raycast forward. We're just going to do a if physics.raycast, and we're going to just do origin direction, and we want the hit info somewhere. Origin direction, hit info. Let's just do that. So transform dot position. We want the lowercase. Transform dot forward. Why is the autocomplete just killing me? And out hit. So I didn't define hit, and that's the reason it gave me wheel hit. We're going to do this like we normally do. It's just raycast hit. So this is our hit info will come out of this, and so that's the reason that we pass it into the function with an output parameter. And all we're going to do is just call this callback. We're not going to do anything else. So we're just going to do callback dot invoke, and you'll see now that invoke takes an argument this time, and this argument was defined based on what we did up here. So it has a raycast hit, so we just throw hit in there. So now if we hit save, let's so what am I going to actually do for this setup? So let's put this on the camera. And let's create another object. Actually, yeah, let's just create a... we'll just use the cube. So actually, let's save this so that... actually, let's save it back where it was cool. Just really quickly. Sorry. Cube. We go to cube target, randomly move. And then we do cube move again. I just want to make sure that this works kind of cool. All right, so I'm going to save this. as random move Unity event. And then we're going to create a new scene. We're going to call this save scene. I'm going to call this raycast move Unity event. So all we're going to do is I'm just going to create in the scene something to raycast against. We're just going to create a big cube. Just going to scale it up on the X and Y values. Then we're going to create another cube. I'm going to call this wall. And we're going to call this cube. I'm just going to put it out here. We're just going to call it cube, I guess. And we're going to create a light real quick. All right, so what we're going to do now is we're going to put so we put raycast with callback. I put that on the other level, didn't I? Hold on, let me just save this real quick and get rid of that on the other level. Because we're not using it really. All right, save. So we're going to put raycast with callback on the main camera. And we're going to then we're going to put our cube in here. And our cube doesn't have a function yet, so we're just going to create a, I'm going to duplicate the randomly move. Oops, that's not duplicate. I don't know what I did, but, and we're going to call this move to position function. That's what I'm just going to call it. And again, this is going to be like our randomly move function. Move to position function. And this is not even going to have parameters. It's just going to have a function called move to position. And all we're going, actually, you know what? We might not even have to do this. But let's just set this up just in case. But I just realized we might not even need this. Transfer.position equals, and then we need a parameter here, right? So vector 3, actually, sorry, move to position. So we've got a raycast hit. So yeah, let's actually to raycast position. I'm gonna just rename it real quick. Save. Just go back in here. Raycast position function. So this will take open it. This will take a raycast hit as a parameter. And then we're just going to say hit.position. Hit.point, there we go. They should have called that position. I don't know why they called it point. All right, so if we put this now on our cube, and then we put in our callback here, we have our cube selected, we go down to here and we do dynamic, so at the top it says dynamic raycast hit, so we go click move to position there. And if we hit play now, we're hitting the cube itself, I think. Here, let's not have the cube not have a collider. All right, so if we go to the scene, the cube's actually in the wall there. I just realized we don't have the ability to mouse look, so let me just really quickly add that. We're just going to go to standard assets, character controllers, sources, scripts, mouse look. Just throw this on our main camera, hit play, and hopefully the defaults will be good enough. There we go. And you can see that the cube is now moving to wherever we're raycasting to. If we get off the screen, it doesn't move again because we have an if for our physics raycast. But yeah, we defined this. We just sent information between two scripts, and all we had to do was define where we wanted to send this information to here, and then have something that could receive that information on the other side. So I'm going to try something slightly different. So if we had set this up so that I'm going to duplicate raycast with callback here. We're going to call this raycast position with callback. And we're going to reorganize this one a bit. So raycast position. So what we were doing before is we were giving the whole raycast hit back. And so I'm going to create a position callback, and this is going to take a vector 3. I'm just curious if this is actually going to work the way I think it's going to. So we're going to put this back in here. So we have a position callback now. And on this one, we, instead of doing callback and vote hit, this won't actually work because hit isn't the right thing. So we're going to do hit.point. So this will now send a vector 3 as opposed to a full raycast hit. So if we now use this one, I'm going to, we'll just replace this for right now. Remove component. We're going to put raycast position with callback. And I'm going to see if we can do this without creating a new script. So we're going to put the cube in here. I'm going to get rid of the script on the cube so that we can show that there's no magic happening here. And we're going to choose game object. Oh, transform. Come on, give it to me. Oh, it does work. So we can do position. If we just do, okay, local position, there it is. So if we just hit play now, this should work just like it did before. It does! That is so cool! Oh, I'm so excited. Alright, so what this means is anything that has a property that is a vector 3 now, you can inject this information into. You don't even have to have it set up with a function to call. You can just be like, hey, I'm returning a vector 3. Anything that's a vector 3, do what I say. And so what you say in this case is go to this hit point. That's basically what you're telling it. You're just saying, hey, here's this information. That's what I want to be in my transform position. This is awesome. I'm so excited. And you can even do multiple return values. You can do up to, I think, 3. Is that how many they did? Oh man, 4. That's more than anyone should ever need. That's so mean. I shouldn't say that. But like seriously, that's awesome that they set it up with that many things. This is so cool. All right, I'm going to save this. We're going to call this a wrap. 3 minutes, I think, was pretty good. I think we did really good on this episode, honestly. I was expecting this to go way worse. Hopefully people were able to follow along. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. And please donate to Cooking with Unity via our Patreon page, patreon.com/cookingwithunity. Really appreciate it. You guys have a great day. We'll see you tonight with more Fight Go Right on 2D Thursday.